Hi and welcome to this second video on partial fractions, and what we're going to do is have a look at partial fractions of a particular format in this video. So we've already done a video and hopefully you've looked at the one where we've looked at just taking our basic ones and writing them as partial fraction, and now we're going to have a look at these things called repeated fractions. There's lots of different structures and forms that these things can come in, and on this course it's been limited to essentially the basic ones, which were these ones which we've already looked at, and then ones that have got repeated factors. So they're not going to do anything to you that is beyond either of those two things. So here we go. What do we mean by a repeated factor? Essentially what we've got is a fraction where the repeated fraction is the squared bit here. And what we've got to do is take our repeated fraction, and the format that it's going to be when we write it as a partial fraction, slightly oddly, is going to be a over x plus p plus b over x plus q plus c over x plus q all squared. So kind of that repeated fraction actually generates two fractions as part of our kind of split apart version. And it's always going to be in that format there, so that's the format you need to go for. I'm not going to go through the kind of the whys or wherefores of it. There is a very good reason for why it looks precisely like that, rather than just two fractions. But we don't need to worry about that at the moment. Let's just bash on. So what we're going to do is take our fraction there and split it out into three separate fractions. There's our repeated factor. So straight away we're going to write it like that. And then again do the multiplying out trick, and everything else kind of follows from the previous structure. So do all the multiplying out. So you'll notice here we've just got the x plus 3 has cancelled. Here we've multiplied out by x plus 3 x minus 2 all squared. So one of the x minus 2's is cancelled and x plus 3 is still there. And over on this one, the x plus 2 all squared is cancelled, leaving us with c bracket x plus 3. And off we go again. Let's start putting in our values. So the first thing I'm going to do is pick a value of x equals 2 in order to make that one 0, and that's going to make that 0. So that gives me minus 5 equals 5c, and spits out c equals 5. Then if we let x equals minus 3, that's going to make that one there 0, so the b is going to disappear. It's going to make that one there 0, so that's going to mean that's going to disappear, so we're just left with the a. And so we've got minus 50 equals 25a. That 25, if we think about it, minus 3, take away 2 is minus 5, square it, that's your 25, giving you a equals minus 2. Now, the thing we're now after is the value for b, but you'll notice that b disappeared both times when we had x equals 2 or x equals minus 3. So what are we going to use as our choice of our third value of x in order to figure out what b is going to be? Well, the answer to that is just pick whatever is simple to use. And I tend to go for x equals 0. And let's just have a look at what happens when we have x equals 0. On the left hand side, those bits are 0, so we're just left with minus 29. And on the right hand side, we've got if x is 0, that's minus 2 squared, so that's 4a. Here we've got x equals 0, so that's going to be 3 times by minus 2, which is minus 6b. And here we've got x is 0, so that's going to be 3c. And you might be looking at it again, well, hang on a second, I've still got three variables, but the fact is I already know my values for a and c. So what I'm going to do now is just plug those values into here. Let's just do that now. There we go. And so what we're left with is b. So all we've got to do now is just a bit of tidying up, and that leaves us with b equals 3. So this choice of x equals 0 is completely random. It was just a really easy one to work with. You could go for x equals 1 or x equals whatever else you wanted. But let's say I find that x equals 0 is the easiest to work with. So we've got our values of a, b and c. So there we go. There's our fraction written as a partial fraction. Minus 2 over x plus 3 plus 3 over x minus 2. Take away 1 over x minus 2. And so on we go. So what we've got here is a cubic denominator, so the first thing we're going to have to do is get that written in factorised form, so we can then figure out what our denominator is going to be in our split out partial fractions. So first job, factorise the denominator. We're going to need a bit of factor theorem for that. So let's go for f of x equals x cubed minus x squared minus 5x minus 3, and let's start plugging in some values. And I know from here I'm going to have a bash at plus or minus 1 plus or minus 3. See what my factor is, so let's try putting 1 in. 1 minus 1 minus 3 minus 5, that's not equal to 0, that's no good to me. If f minus 1 gives me minus 1 plus 5 minus 3, that one does equal 0, so therefore if and put in a value of -1, that means that x plus 1 is going to be a factor. So therefore, my f of x looks like that. And so I need to figure out this bit here. So that's going to be a quadratic. So you can either do this by division, or I'm just going to do it by inspection. So here we go. Well, I know that that bit's going to have to be x squared in order to give me the x cubed. I also know as a result of the constant term, that means that bit on the end is going to be -3, and it's the middle bit that's always a little bit more tricky to figure out. So what I'm going to do is have a look at the x squared terms. Now I've got 1x squared coming from there. I need to make this thing into -x squared. In order to do that, that means this middle term here is going to have to be a -2. So there we go. So that's it, factorized into a linear factor and a quadratic. And then the final job is to finish off by factorizing the quadratic. There we go. And what do you know? A repeated factor has popped out. So therefore, our fraction looks like that. And therefore, my structure for my partial fraction looks like that, where I've got my initial bit with the x plus 1. There's the repeated factor. And then I've got the x minus 3 as well. Right. So let's now do the partial fractions job on all of this. So there we go, multiply out by the denominator by multiplying out by x plus 1 squared bracket x minus 3. And then start picking some values. First of all, when x equals -1. So we've got b equals -1. When x equals 3, gives us c equals 1/2. And when x equals 0, there's my choice of random value, just to kind of make my life easier. So I've got those bits, and that gives us a value of a equals 3/2. And part of the reason that I kind of decided to use this example is just to show you how to deal with fractions when it comes to fractions and partial fractions. You could just put this in and write this bit here as 3/2 over x plus 1, but that's a little bit on the messy side. What I prefer to do is write it like that. So we've got 3/2, so there's my value for a there, over x plus 1. And then we've got minus 1 over x plus 1 all squared. And then for part C, again, I've got 1 over 2 x plus 2. And there it is, all done and sorted. And you'll notice from that example as well, there's, when you get to year 2, there's lots of other bits and pieces that kind of come in. We noticed in order to get to this one, we had to go back and we had to use our factor theorem to help us do the factorizing. So a lot of the algebraic tricks that you had in year 1 of the building blocks to enable us to break apart stuff in year 2 and deal with more complex things when we get into the year 2 content. Cool.